So this event has kind of a special footnote to it. Did you guys notice that this is not the gathering of software architects? It's the software architecture gathering. So it's a valid question, who here is actually an architect? We want to make sure nobody else snuck in. Okay. Who knows people who have the title architect, but you don't actually consider them very capable architects? Okay. All right. Also happens. Who hates talks that start with the speaker asking you to raise your hand? Okay, I also do. Well, thanks for playing along. Yes, so architecture is an interesting topic, and architects are sort of meant to be the people who do architecture, but because there's so many definitions of what architecture really is, well, that also leaves us with a lot of question marks of what architects are. Is it something that's written on the business card? Maybe, as you guys voted, right? I also know people who I would say are great architects but don't have the title on the card, and also vice versa. So there must be something a little bit different about what makes a person an architect, so they are legitimately invited to the software architect gathering. And yes, I start with a provocative statement of saying we shouldn't have to be the smartest people in the room, and that's actually very good because the bigger the room gets, the harder this becomes, but rather we are the people who make everybody else a little bit smarter. So the role of the architect isn't sort of this classic definition of you make the really important decisions because, you know, you're the one who is qualified to make the really important decisions, whereas all the other people who might be not quite as smart, right, they make the less important decisions. It's a pretty silly idea, right? How could you know better than all the other people, right? How would one person being able to make all those decisions? Makes very little sense. So rather, you help the other folks who are closer to the action, who often have more information, you help them make better decisions. And that's a fantastic role to have because it makes you an amplifier, it makes you a booster. In the end, it makes you an IQ booster for everybody else. And I think that is really a fantastic definition of what we as architects should be doing. Now, the question is, how do we do that? And I have a few tips for that. The one question I often get is, now, which architect is the most valuable person? You know, as we heard in the introduction, I've done many different things. I used to be a chief architect, right? Sounds pretty important. I used to work in Silicon Valley companies where actually no one had the title architect. We didn't like architects because we considered them the people who just, you know, draw pictures and don't understand reality very much, right? So there was a notion that the real valuable architects would be the hands-on one, not the chief architect. So in the end, I come to the conclusion of asking this is really the wrong question. Looking at this as some sort of hierarchy isn't the way you can determine the value of an architect, because the most valuable architect is not about which level you sit at, but it's about how many different levels you can actually connect. So if you're a very hands-on architect, but you have a clear idea where things are going, it's connected to business value, business strategy in your business domain, that is highly valuable. If you're an enterprise architect, and yes, you float sort of almost in this proverbial ivory tower, but the things that you do in aligning the IT strategy with the business strategy and translating that into making sure that the other folks build things of the highest value, that is also highly valuable. So it's not about your title, it's not about which floor you're on, but it's about how many floors you can cover. Because if nobody connects the floors, you have a serious problem. And the problem is if the folks in the engine room build fantastic stuff, but it doesn't line up with what the business needs, coding faster does not help, right? If the tunnels don't meet, right, you don't need to dig faster. You need to somebody who gets things connected. Now you might wonder, well, why wouldn't the tunnels meet, right? Don't we have all these, steering committee and architecture reviews and all these fantastic things that we all love, right? Aren't they all there to make the tunnels meet? Well, in many large organizations, it is not that easy, right? They have many floors. And what you get to is, upper management lives in a happy illusion, right? They were told that the IT has GenAI, it has blockchain, and it has containers. So they are convinced that everything is in very, very good shape. And vice versa, the technical team knows that management doesn't really know what they're doing, so they enjoy their freedom, right? And how can this work is, well, there's this isolation layer in the middle that's called middle management. It's a unlucky case of organizational loose coupling, right? It decouples leadership from implementation, except in this case, that is not a very good idea. Right? So this is exactly how the tunnels miss each other, and that's a very important role that architects do, is to create this kind of alignment, right? And that's what I call the architect elevator, or in this case, the person is the elevator architect who shapes that kind of connection, right? And I wrote a whole book about it, how you do this, how you better communicate with management, how you distill technical decisions to the right trade-offs, how you get decision discipline, how you draw good diagrams, right? And so on and so forth. So forging this connection is one of the first things architects do, and they make everybody else smarter, or they make them at least more valuable by making sure that what they work on actually lines up with the business value that it's supposed to achieve. Now, when you talk to folks across different levels, they have different base knowledge, right? There's different things that developers will understand versus maybe even a CTO, but certainly a CFO or a CEO. They have different backgrounds, they have different ways of thinking. They're all very smart people. So one of the biggest mistakes that I see folks who try to communicate to management, the mistake that they make is they tend to dumb things down, right? Because they say, oh, all this technical detail we have, right? They're just managers, they don't code all the time, so they don't understand our details, so let me make this simpler for them to understand. And they water it down or they dumb it down. That's about the worst thing you can do, because you're talking to some of the most accomplished and intelligent people in the company, right? They just don't tend to be programmers, right? They can't argue about, statically or dynamically typed languages, but they're certainly not the people that you want to dumb things down for. They're not dumb, right? So this will absolutely not work. So instead, a really good vehicle you can use is to use metaphors. You translate the characteristics and the trade-offs of your world into another world that they can understand very well. And then you can think together. So I'm famous for using a lot of car metaphors, right? So this is about friction, I once called serverless a halo product. It's about how platforms work, how disruptions work, and why calling something the gas pedal is a poor abstraction, because electric cars don't have gas, or hopefully not in the batteries, so we should call this thing the accelerator, which is the proper term. So you can explain many things with metaphors and car metaphors, only shortly followed by all the train metaphors that I use, right? How do train wheels stay on track? Not because of the guardrails, but because of the actual shape. So that's how projects should stay on track, not by hitting guardrails. Nobody drives around by hitting guardrails, but by having a shape that keeps the project in line. If you want a car metaphor for this, I have a saying that is, every time there's a guardrail, you also need lane assist. And the lane assist is there that nobody actually ever hits the guardrail, because hitting the guardrail is a bad thing. Both the car is wrecked and the guardrail is wrecked, so nobody actually likes those. So these metaphors have this nice property that it translates what we do in IT into another domain. Oh, this is about don't burst the boiler, right? If you have a steam engine and somebody is using different technology that's inherently faster, like an electric train, your first reaction is to put more coals on the fire. So I tell people, well, the only way this leads is not a transformation, that will lead to a burst boiler. So I'll tell people, don't burst the boiler, rethink the way you're working, right? So these metaphors are sticky and they're familiar and they allow people to think along with you. And that's the most important part, because if they don't think with you, it's an underutilization of company resources, right? You work for the same place, you're talking to intelligent people, but you're shutting them out of the decision process. That is a waste of intellectual resources, not a clever thing to do, right? So you should involve them. And B, right, when you talk to the average executive and you talk about this whole project proposal you have and all this architecture, and it's all like loosely coupled EDA, kind of microservices, this and that, and here's my project proposal. Really what you're telling them is, trust me, right? Because everything else to them is just like, a little bit vague mumbo jumbo, right? So they may trust you, right? They might in fact do that, but having them actually understand the decisions you're making and the trade-offs is a much better foundation to build on than just trust me, right? So, and that's what metaphors can do, that allows people to think along with you by giving them something that they understand that has similar properties to the thing that you are actually discussing. Now, if somebody wants to splice hair in pure rhetoric, like in language, people distinguish metaphors from similes. So people say a metaphor is if you call a thing something else, like say, oh, the defense is an impenetrable wall, that's what's called a metaphor. And if you say the defense is like an impenetrable wall, that's called a simile. That's for like rhetoric and people making speeches, right? This is about getting people to understand stuff. So I'm very happy to call these things metaphors, right? Even though we don't claim they're the same thing, we say this is like something else, right? It's like bursting the boiler. It's like the gas pedal. So for me, that is fine to call this a metaphor. The core when I talk about what makes architects architect, right? Because we already concluded it's not about being smarter, it's not about having something on the business card, but I find myself in many conversations where I either myself or I see other people see things from a slightly different point of view. Right? The architect might come into a discussion that's a little bit stuck, or people argue over something, and then the person who might be called architect or acting as an architect has a different view, and they said, hey, have you guys considered this? You can have both of the things you're arguing about, right? They see things from a slightly different dimension. And this is one of my favorite sketches because I see this situation very frequently. Right? This is the situation where people argue about A versus B, right? They say, oh, we need to do this, so we need to do that. So one person says, oh, this is clearly a circle, and the other person says, I have no idea what you're talking about. This is clearly a rectangle, because they look at the cylinder from two different points of view, because they're stuck in a two-dimensional world, right? As an architect, if you see the third dimension, you're like, hey guys, you're talking about the same thing here, right? Classic conversations. This is stuff like, hey, we need to accelerate the project timeline because we committed to a public deadline, product launch, whatever it might be. And the other people say, we cannot compromise quality, right? And they will go back and forth because the assumption they're making is that if you speed something up, you compromise quality. They see this as left or right. You can only have one or the other. And only having one or the other is kind of depressing, is very sad, right? Because either you're late or you have shoddy quality or a little bit of both, right? You will never be happy. As an architect, you guys all know the answer. Things like testing early, automated testing, short release cycles, rapid feedback, right? Those are all good ways to get both, right? You can deliver faster and generally with higher quality. So the things are not on one dimension, it's not left or right, but you can actually have both. So seeing more dimensions is very powerful. It gets out of a lot of frustration and a lot of argument. The sort of fancy way of saying this, I call this, you expand the solution space, right? You give people more dials, more dimensions on which to build a solution, and then they can come to a much more better, or at least more amenable solution, right? And that's one way you made them smarter, in this case, probably also happier. So classic example, used to work for cloud providers. So our favorite, unfavorite topic was always lock-in, right? People say, oh, your stuff is fantastic, but am I always going to be locked in? I said, and the providers don't like to talk about it so much. I said, well, if we're customer obsessed, we should talk about the things that our customers want to talk about. And if they want to talk about lock-in, we should talk about lock-in. But we should help people think differently about lock-in. So the first thing is lock-in into a certain tool or product or cloud, whatever you have, is a matter of switching costs. Nobody gets locked up. Nobody goes to jail, right? It's switching costs, right? How much does it cost me if I change my database, my cloud provider, my whatever tool, right? Even if I change Kubernetes version from one to another, it has a switching cost, right? Upgrades are not free. So first what I realized is I saw shades of gray. Rather than making this ominous FUD thing, I said, hey, it's switching costs. It's just about money. And where there's cost, there better be value, because if there's no value, we have no discussion, right? So now you have two dimensions, like how much utility, how much value are you getting out of using this tool versus how much potential switching cost you're accepting. Now you have two dimensions. You can have a whole different discussion. Right? An old friend of mine, Adrian Cockcroft, always had a nice way to explain the top right quadrant, right? The accepted lock-in. He would go around the room and says, well, who here is worried about lock-in, like cloud event, right? Everybody puts their hand up. And then we'd say, well, who here is married? And then everybody kind of looks at their hand and is like, well, I have no advice on that regard, but, right, there are benefits to long-standing relationships, and a two-dimensional model can help you see that. So, yeah, where there's cost, there's value. You have a different discussion. This is a classic architect making people smarter maneuver. And now, if you go on the cost axis, the switching cost, you can break that down into many different dimensions. Normally, people talk about switching vendors, but you might be switching products. If you switch from one open source product to another one, you also have switching costs. I just mentioned, right, versions. You use an open source product, you use Kubernetes, you upgrade from one version to another, that has switching costs. So you're locked into a specific version of an open source product, right? If you're honest about it. And I know this for sure because at AWS, I always joke, one of the least favorite features that we released was extended version support on EKS, right? Why would you need, and we charge people nicely for this, right? To have older Kubernetes versions on the managed Kubernetes, right? And why would you have this? Because people are on older versions. Why are they on older versions? Because upgrading costs money, right? So they're locked into an old version and they happily paid money to run an old version. So this gives you much more clarity on what's going on there. There's many different dimensions, and all these dimensions together make the switching cost dimension that stands against the value dimension, and now you can make a decision. You made everybody smarter by giving them a more powerful mental model and expanding their solution space. So I haven't quite finished this completely in my head, I have to say, but so I'm trying to capture some of these architect maneuvers. Like, what are kind of the tactics that architects use that expand the solution space, right? One very obvious one is granularity, right? People need to decide, and we had this at the insurance company, said, oh, we need to buy an integration tool. And people were looking for one answer. And the end we realized is we don't need one tool for everything. We got like mainframes and old stuff that has very different needs than a modern distributed system that might need an ESB or an EDA, right? It's like Kafka is not going to be for the mainframe, and the mainframe stuff is not going to be for the modern app. So we split this into multiple pieces. We didn't make one decision, we made multiple decisions, and that expands the solution space, right? We had more we could work with. One classic maneuver. Other one I just mentioned, dimensionality, right? Left or right, you'll never be happy. Can you have both? Is this two dimensions? And decoupling, right? You have different concerns, but they seem to go together. Can you detach them, right? Can you decide things independently? So I'm thinking about expanding this kind of catalog because of the easy techniques that are immensely powerful to get people to see the solution space more clearly and in the end come to a better decision. One of the biggest traps I've seen, I call this the logic hourglass, where people start, and you see this in any IT presentation, right? Where people proposing the project or pitching anything, right? It starts with, the latest trend, buzzwords, what they try to achieve, right? Is very big. Here's all the fantastic stuff we're gonna do. Then it gets very, very thin, and out comes, we need like 5 million euros, 20 head count, right? This many servers, or this much cloud budget, right? Out come the demands. And the executives always wonder themselves, like, how are we get from up here to down there. And then we rely on FOMO and FUD. Oh, if we don't do it, we won't be competitive. We'll be hacked. We go out of business, or we arm wave our way through from A to B. And I just said executives are some of the most accomplished, most intelligent people in the company. So I guarantee you they're not going to fall for this thing, right? And I've seen a lot of really awkward meetings where the executives felt like this thing is somehow not adding up, but they didn't have the technical lingo to really challenge the people, and you immediately know these are the kind of meetings you don't want to have. This is when the elevator is broken and you're taking the stairs, and it's going to be extremely, extremely painful. So another one of these maneuvers that I started naming is the architect boomerang, I call it. Like, too many times the answer is presupposed, like, oh, we need to be cloud native, and here's Kubernetes, or here's container. It's like, boom, it's just like sort of presupposed. People jump very quickly to the solution without really understanding the problem, right? It's this famous Einstein quote, if I had 1 hour, right, I would spend 50 minutes, thinking about the problem. This is exactly this. You take a step back and you look really, why are we doing this, right? The 5 why methods, what are we really after? We're like, oh, we're going to the cloud. Well, that's not the goal. We're going to the cloud because we want other things, right? Maybe we want more resilience, more uptime, easier updates, right? There's other things we want. The customers don't see if we're in the cloud or not, right? The people are like, oh, we migrate 80% of the servers. Well, why do we migrate 80% of the servers, right? There must be a purpose. So you backtrack to really understand what you're after. And once you're doing that, your solution space goes up. Right? You have many more options to achieve this, right? It's not this one thing that you can pick. You can pick many more things. And then you have principles that guide you towards which solution or which option is actually the most preferred. And you come to a much better informed decision, and you understand the trade-offs, right? This is like you back up and you come back with a deeper insight and a better shared understanding of your decision. Everybody got a little bit smarter, especially the folks who are not technical or not architects, right? They can now understand how we got from A to B, and they will be supporting you much better, right? You're buying yourself with that also some support. That's the elevator in action. One of my favorite metaphors for what architects do is we sell options. I used to work in financial industry, right? So another metaphor, right here, options trading for architecture. If you work in the financial industry, executives will very easily understand what options are. So the way the options trading works is we give up some options to gain others. So let's say we want a choice of programming languages. Some teams prefer stuff on the left, other teams prefer or need stuff on the right. Well, very easy architecture quiz here, right? Everybody is a winner. What you do is you pick common protocols between those, right? You separate them into services. Chris was just telling us all about it. You make a common protocol, and by giving up the option of having 50 different protocols, you gain the option to have more diversity in programming languages. You made a trade. You locked down some things, but not to constrain people. And that's like the interesting part. You lock down things to actually have more choice, right? And that's the subtitle of my book on platforms. Is called Innovation Through Harmonization. You harmonize some things, but in return, you get more diversity, you get more innovation, you get more variety. So that's how you're trading these kind of options. Now, the powerful thing about metaphors is that you can think along in the metaphor. An option is a financial construct. There's a whole science about it. People get Nobel Prizes in economics. So once you use this metaphor, the metaphor can help you think along. And you end up with fantastic stuff like this. So this explains the value of architecture. And it explains it in the same way that if you talk about containers and Kubernetes and cloud native and loose coupling, to the financial executives, that will appear exactly like this, because to them, this is totally obvious. To us, it isn't. Power of metaphors. It also gets you to be in the passenger seat. right? This is when somebody talks techno mumbo jumbo, right? Which to them is totally obvious. This is the Black-Scholes formula of option pricing. Of course, you guys all knew this, right? And this proves that options have value. So if architects provide options, the options have value. It's easy to see. As an architect, I can give you the option to add or remove hardware later. I do that by giving you an elastic infrastructure, the cloud, right, if you like, and I give you automation and I give you a scale-out architecture. So now you can add or subtract capacity as you wish. And of course, that is worth money because if you predict capacity, you'll always be wrong, right? You'll be wasting capacity or your app won't run. So the option to defer this decision, right, what you're doing is you're deferring a decision into the future. That always has value. Intuitively, very easily, because in the future you're smarter, right? If you defer your sizing decision to the time where your application actually runs, well, you know the resource needs, right? You're smarter in the future than you were, so deferring decisions into the future is valuable because you're smarter, you make better decisions. And this is the formula behind this, right, that proves it. Now, if you want to stretch the metaphor and play with the metaphor a little bit more, there's a magic character in here, it's the Greek sigma. And that is the volatility. Right? It's like sigma squared is up there, there's a sigma in the denominator, but there's a sigma squared in the back that wins. So the more volatility you have, the higher the value. Why is that? Well, intuitively, let's come back to server sizing, right? If I have 5 users and the number of users never changes, deferring the decision of resource sizing just isn't as valuable, right? I do it once, it never changes, I have no uncertainty, it's totally fine. If I launch a mobile application that might have 100 users today and like 100,000 users in a week, that option is highly valuable because the volatility goes up. So we learn a couple of things here, right? The first thing we learn is these metaphors are powerful because by translating what we do into another world, that world can teach us things about what we do that we didn't necessarily understand. So high uncertainty, high volatility actually increases the value of architecture, right? These architecture options are more valuable when I have uncertainty, and that comes out of this formula. It leads to another interesting conclusion. So now I said the more uncertainty you have, the more volatility you have, the more valuable architecture becomes. There's another common way of working in our area that also starts with A and that also thrives off uncertainty, and that is agile. Right? If we know everything and nothing changes, what do? We write it down, we implement it, we're done. We don't need stand-up meetings and iterations and all this kind of stuff, right? Would be so easy. Now, why don't we do this? Why do we follow agile methods? Well, because that's not the world we live in. We deal with uncertainty. We don't know everything. Stuff is changing. Competitors launch new products. Regulators make new laws and rules, right? Many currencies get devalued. Like all sorts of things happen. Global trade tensions come, right? There's stuff that we don't know, so that's why we're agile. But that leads to an interesting conclusion, right? So the classic dialogue is the one where a person talks to the architect, and the person says, "Oh, dear architect, I find what you do fascinating. But you know what? We're an agile project. So, you do your thing, right? And we're over here, we do our agile thing, you do your architecture thing, and we'll all be happily separated, kind of, right? In our kind of thing. So now you have a very clever answer to this, right? Somebody says, "Hey, we're agile." He said, "Oh, great, right? You're probably agile because you deal with high levels of uncertainty." They say, yeah, tons of uncertainty, right? And agile, iteration, all this kind of thing. And you say, "Funny thing, you should say that." Me too, right? Because I, as an architect, the value of architecture thrives off uncertainty. So they live in the same environment. And if you need a car metaphor for this, right? There's always another car metaphor is, the architecture is the gas pedal or the engine. The architecture keeps things moving and makes sure that you don't come to a grinding halt. And agile is the steering wheel. And one without the other makes no sense, right? If the engine isn't running, you can steer all you want, nothing comes out. And going without a steering wheel very fast, probably also a bad idea. So you need both. So there's a car metaphor for you, right? engine or gas pedal and steering wheel, and both of them live in the same environment. And yes, there should be a little bit more love for architecture and agility, right? Both thrive on uncertainty, right? And that is like what makes us smarter, right? We went like, oh, we saw more dimensions, then we went to Black-Scholes formula, we talked about options pricing, we talked about uncertainty, then we jumped into agility, and then we come back, right? This is the boomerang. And then we come back and we have this sudden insight. It's like, yep, architecture and agile are not opposed at all. They actually thrive in the same environment. That's how we make people smarter. Architects are sometimes, called the people who draw a lot of pictures, or sometimes they're a little bit belittled for drawing too many pictures. I like drawing pictures, right? Pictures are very valuable because diagrams and pictures are models, and models are one of the most powerful tools that architects have to make other people smarter and also to make better decisions. Because the biggest enemy we have is complexity. Right? We should be fair. The kind of technology we can build today is pretty awesome, right? We can build fully distributed, auto-scaling, eventually consistent, runtime, loosely coupled applications left, right, and center, right? It's amazing what we can do. They're resilient and self-healing, and what they not all are observable. They are, right, all the things they have, but the one thing they're not, and that is simple. Right? This stuff is complex, right? So complexity is our biggest enemy in this, and the best antidote against that complexity are models, because they help us think about this kind of complexity. So models shape our thinking. So I actually stole this from Dave Farley, who I'm sure stole it from somewhere else, right? This is the solar system. Right? And there, in past times, were two different models about how the solar system is arranged, right? So the church was very much saying, hey, we are on the planet, God made the planet, so we must be in the center of the universe, Seems a little bit self-centered, quite literally, but man, that's the way it was, right? And Copernicus was the one who's like, if I put the sun in the center, things look very differently. So if you believe in the geocentric model on the right, it's pretty cool how these planets can make these amazing, turns, right? It's just kind of, it's almost like, what was the guy always like, Gymkhana, right? The guy who driving the rally car and going around the turns, drifting, right? This is like the planets are kind of doing this. Should make you wonder a little bit, right? Now, on the left-hand side, right, where the sun is in the center, now everything makes sense. So the model really determines the way you look at your environment. And a couple of things follow out of this, right? The first one is, these models are all totally wrong, right? The solar system isn't just this size. The solar system isn't two-dimensional. The planets are not little red balls, and they also don't move in circles, right? This is wrong on like almost every dimension that you can think of, but it helps our thinking. That's the purpose. It's not meant to be a life-size accurate depiction. It's meant to be an abstraction. And the other thing that we learn is the simpler the outcome, the simpler the model, that probably means that you had a good model. Or as I say, the easier the answer pops out, that is probably a sign that you used the right model. It can be a little bit anticlimactic, right? If you look at your problem from the right angle, suddenly things are obvious. And some architects I know, they get a little bit nervous about, did I provide enough value? Because I should be answering these complicated questions, right? I'm supposed to be making these big decisions. And when suddenly these decisions become simple, they get a little bit nervous. But the effect is exactly the opposite. When things suddenly start to look simple, that's probably a sign that you actually picked the right model. So that's what models do for us, right? There's always clever people, and we like these kind of quotes, right? Where I just said, all models are wrong. The planets are not little red circles. Last time I went for a hike, I didn't exactly see the contour lines on the mountain, right? These are all abstractions. So the funny insight out of this is actually that when we make models, we don't want to draw reality. We want to abstract. Now in IT, we often get this backwards. What we like to do is we draw these tapestries. right? They're impressive, but they're not good models, right? This is like trying to draw the solar system in 1:1 scale and make it really accurate. And it's like, well, look, everything is on here somehow, but it didn't really make us smarter, right? I always say a model needs to help you make better decisions or help you answer a question. There's not a lot of questions that this thing answers, except maybe, why does everything take so long and cost so much money? Right? And it doesn't really give a very precise answer. It might make it more plausible, but it doesn't tell you what to do about it. Right? So the tapestries are the worst models because they're the too detailed, over-elaborate models, right, that George Box was commenting on. You want simple, evocative models. You want models that help you make that decision. So if you make the model simpler, a valid question is, well, which model is the right one? Right? And here we have some choices. To not trick you, I picked a system that we're all rather familiar with called Planet Earth, right? Most of us been there at some point or another. So the system is fairly clear, but there is 4 different models, right? 4 different depictions. And they're all wrong, right? I mean, Germany is not dark red, the highways are not orange, the contour lines are not there, right? They're all completely wrong, but they can be useful. Now, models are never right or wrong, because we already concluded they're all wrong. So they can be fit for purpose. They can be useful. And what they're useful for depends on the question that you have. There's not one most suitable model in all cases. So give you some questions that fit these models. The top left one is clearly, I already mentioned, I go for a hike, and I want the hike to be not too hard, right? Topographical map, very useful. I might be doing the opposite. I might want to build a ski resort, so I do want slopes. Again, this model is very useful. I might want to build a house outside the flood zone, also very useful. I might want to build a dam and see how much capacity the dam holds and how many houses I have to move. Also very useful, right? These simple models answer a lot of questions, right? So bottom one is, what's the fastest way to drive from point A to point B? It's a highway map. I always joke the model on the top right is supposed to explain to us how the US elections work. I'm not so sure about that, but that's not the model's fault, right? Don't blame the model. And if anybody has a guess at the bottom right, that is a population density map, and that answers very important questions for people who build distribution centers, e-commerce, right? They have a combination of transport and population density maps, and that's where you build your warehouses. So the model used very much depends on the question you have. Now, every architecture diagram is a model. So when somebody comes to you and says, show me your architecture, a valid question or valid counter question is, well, what question do you have? Because the question that you have, I'm likely to show you a different model. There is not one architecture. The real architecture is in the system. That's planet Earth, right? Everything else is model. So if somebody wants to see a model, but they don't tell you what question they have, you cannot really give them a very good model for this. So it's a very valid retort to say, hey, what decision are you looking to make, or what question do you have? Because that will help me understand the model that will best do that, right? And again, that makes everybody else smarter. So as I said before, right, when the answer is obvious, don't be nervous. That is really a sign of you having picked the right model. It's a little bit anticlimactic, but it's fantastic. Everybody looks at the thing, everybody says, yeah, obviously it's going to be like this. That means you've done an excellent job as an architect. You made everybody smarter and you got everybody to agree, which is even harder. Couple questions I get a lot. Yeah, I'm good friends with Simon Brown, like C4 model and other standard architecture diagrams, right? So I say there's not one model that answers all questions, so I'm advocating making different drawings, different sketches. So there's a valid question, well, does that contradict things that like Simon is doing, where he said, hey, use the C4 model. So I come to the conclusion that these models still serve 2 very different purposes. The one is to make a decision and get clarity on what you're gonna do. And for that, I find the custom models to be most useful. The one that is geared towards answering this one specific question and giving the team clarity of thought on what to do. They're not as good at communicating. Because if you make a custom model, right, to people who weren't in the room, they might not know exactly what the visual language you use. So if it's for communicating to a large group, standard models do a better job, right? Once the decisions are made, here's what we built, right? C4 model is fantastic for that. Versus here, if you're in the stalemate about making a decision and you can't get clarity, that's often where you need a rich custom model to really get to the essence of the kind of problem. And that's why I think, again, there's no contradiction here. Both models are valuable in their respective context, right, where they're being used, whether communicate or making decision, two different things. Now, we talked a lot about sort of the intellectual part, right? Like models and thinking, decision theory and options and principles. Now, obviously, as architects, we live in a context of people. We live in an organization. And the tech is relatively easy to deal with, but also you need to deal with people who have different opinions or resistance. So as an architect, if you don't align the organizational side with the technology side, you're not going to get anywhere, right? The one cannot exist without the other. We talk a lot about socio-technical systems. They cannot be isolated. So as an architect, you also need to deal with resistance, and this is usually human resistance, and no resistance here is not futile, right? You should make lemonade from lemons. It's another metaphor that we use to deal with resistance. So the failure mode number one that I observe all the time is technical folks talking to non-technical, usually non-technical people who have more power than they do, people who give budget and headcount, right? So you're asking for something and the people don't agree. They say, no, your cloud-native container, serverless, auto-scaling, loosely coupled thing. I'm like, yeah, I don't know, that's worth 40 headcount. The classic reaction is, oh, you don't understand. Let me explain this to you one more time. And I talk a little bit more slowly and a little bit louder, and I'll be a little bit more belittling to you, so you will finally agree with me. Now, fantastic. How is that going to end, right? It's like there's little uncertainty in that scenario, right? That's going to end in absolute disaster, right? You're talking to smart people, they don't agree with you. The key thing that you need to do is you need to understand their beliefs and assumptions that make their actions rational. Right? People are not always rational, but as a going-in assumption is you need to take a step back, boomerang, right? And understand under which circumstances would their point of view be rational, right? For example, if you say, hey, we're going to deploy 100 times a day and people come over my dead body, right? You're like, come on, how can they not understand? You say, oh, maybe we deploy 1,000 times a day, right? Like even better. And they're like, no, that's even worse, right? Like, and where do they come from? They might have real life experience that showed that speed degrades quality. Like in the old days, that was probably the case. Somebody made a quick patch and then everybody stayed up the whole weekend trying to fix the darn system, right? They have that experience as a real life experience they have. Based on that, they have a belief that speed and quality are opposed. So if you pitch higher speed, they hear lower quality. And the more you pitch more higher speed, the more they hear more lower quality, right? And this is guaranteed to be a car wreck, to use a car metaphor, right? So what you need to do is you need to back up and understand what they have to have in their mind, because they'll never tell you straight out. So you have to debug, like reverse engineer, right? We like debugging. You have to reverse engineer this, and you cannot change their behaviors if you do not change their beliefs and assumptions. So you owe them an explanation. Say, yes, I know we had the stories where we did rapid releases and it led to all sorts of operational issues. So here is why now it's different. You owe them this answer. And only once that is done can you start with your rapid releases, right? This is failure mode number one. If you face resistance, you bang your head against the wall and all you get is a headache. The wall is not going to move. You might get other forms of resistance. So one I often get, it was funny, a big German company, people always say, oh, this is too academic. And the people who said this are Herr Doctor and Frau Doctor and more Doctor, right? It's all the PhDs, and they tell me, oh, this is too academic. I'm like, okay, this is already a little bit funny. But in the end, people come like, oh, we need to make a decision here. I have a great strategy for this. Somebody says, I don't have time for your architecture stuff, right? We just need to make a decision. You get a coin. And he's all right, you want a decision, heads or tail? And they will say, oh, you can't do that. I'm like, yes, I can, right? All you wanted is a decision, right? Like, here it comes, right? It's very quick, and we can't even argue, right? And then people say, oh, this makes no sense. And you're like, right? Because we want an informed decision, right? We want to know what we are deciding. We want to understand the ramifications. And you know what? Thinking has a very high ROI. Once the right people in the room and they participate and they think together, it is incredibly fast. What takes all the time is all the stupid coordination and disconnects and people hiding information. That's where all the time goes. Thinking through the problem with a good model is incredibly fast. So yeah, if you face resistance of, let's make a decision, you help them make a decision, and very quickly they will realize that how absurd their request was. Another form of resistance you may face is that people say, oh, you're over-engineering this thing. Don't make it so complicated. Similar to the decision, they make a plan and they believe the plan answers all their questions. I actually had this in a very large insurance company. My going joke was exactly this. We always had excellent plans, and when reality wouldn't match the plans, we blamed reality. Because reality was obviously wrong because our plans were right. I call this the illusion of predictability. Yes, everything could be so much simpler if nothing changed and nothing was uncertain, right? If life was predictable, right, I can make perfect decisions all the time. Now, anybody who's taking a tiny bit of logic classes knows that from a false assumption, you can prove anything. Right? If you make a mathematical proof and you say, assume 1 equals 0, you can prove anything you want, right? So the key here is you need to go again a little bit upstream and say, look, I like the way you're thinking, but the base assumption doesn't hold. Yes, this would be much easier, but we're not there because the base assumption doesn't hold. Our world is no longer as predictable as it used to be, and that's why we're using different methods and different models and different approaches. So hopefully I've given you some hints about how to become smarter as an architect who makes other people smarter, right? It's a little bit meta here, right? But this is the amplifier effect. So I'm like the double amplifier, if you wish. I hope I am, right? Where it's really about connecting levels, right? If the tunnels don't connect, right? Digging faster is no good. Metaphors invites your audience to think with you rather than just trusting you with your domain that they don't understand. Getting people out of this deadlock of A versus B, seeing more dimensions, extremely powerful, this architect boomerang. What are we really after? Do we have more options? Do we understand the trade-offs, right? Those are things that are extremely powerful. Setting options, Black-Scholes, uncertainty, agile and architecture are actually friends. Models your best weapon against the complexity, and yes, you thrive on resistance, you flip the coins, you make organizational lemonade out of lemons. That leaves me only with 2 items, and that obviously there's one missing here. You guys know my love for the Matrix movies, right? My books are full of the Matrix stuff, so I always recommend people watch the Matrix very carefully. A lot of things are to be learned about architecture from that, and all the rest I wrote down in some books. So if you like this kind of stuff, visit my website, talk to me later when we have some drinks, and thank you very much.